Let's say that the information we have here represents a study done on some engineering, business, and performing arts students. And the study tested what part of their brain was relatively strongest. Okay, between left, right, visual versus auditory, and motor skills. Of these three, which one had the highest relative acuity? Okay, so we find that 60 of the engineering students had higher acuity in the left than in the visual or the motor. 47 were higher in the visual than they were in the left or the motor, and 38 were higher in the motor than they were in the left or the visual. Okay, and this doesn't represent a real survey. These numbers are made up. There's no real validity to them. But let's say now you have some business students, and that 73 of those had a strong left orientation, left brain orientation, 42 a strong visual orientation, and 59 a strong motor orientation. Okay, we're strongest in the motor orientation. Okay, so again, 73 were stronger at the left than in the visual or motor. 42 were stronger at the visual than the left or the motor. 59 were stronger at the motor than the left or the visual. I'm not even sure how you would measure that, and I'm not sure it would be valid, but let's just pretend it is, and go on and answer some questions. Now, what's the number in the set L intersection B, where L stands for the number of people with the left, whose acuity at the left was higher than visual or motor, and B stands for business students. So L intersection B, well, let's see. We might do a little color coding here. Let's say that we're going to do L intersection B like so. Here's L. Here's B. Where do they intersect? Well, the intersection's right here. So the number in the intersection of L and B is 73. What about LUB? Well, we can use the same highlight, except that LUB is going to consist of all these, right? So if we do this, we see that the number in LUB is going to be 60. We're going to have the 60 who are here, the 73 here, the 41 here, and the 42 and the 59, so that when we add those up, we're going to get the number that are in the union of the two sets. Now, the union means people who are either highest left orientation or in the business curriculum, and as long as they satisfy at least one of those criteria, they count. Okay, what about V intersection E prime? Let's choose a different color to highlight this one. V is visual, so let's go ahead and circle that set. And then what about the set E prime? Well, E is a set of engineering students. E prime will be the set of students who are not in engineering, and that's going to consist of all these. Now, what is this? It's the intersection of V and E prime. Where do these two sets intersect? 73 is not in the intersection because it's in E prime, but it's not in V. 42 is in V, and it's in E prime, so 42 is going to count, and so is the 93. The 41, the 59, and the 87 are not in V, so they can't be in the intersection. So the intersection will just consist of the 42 and the 93. Starting off with a bad 2 here, 42 and 93, and you can add that up. It adds up to what, 135? Okay, and then M union B prime. Okay, now, where's B prime? Well, better have a good color for B prime. Let's see. I guess we'll go with the brown. Okay, B prime is everything that's not in business. That's going to consist of the engineering, and the performing arts. So we see that we've got this two-pronged region here that encloses the engineering and the visual arts. And then B prime. Oh, that is B prime. Okay, M. M union B prime. So M is the motor, so we're going to include the motor, and we're doing the union. So we're going to lump these two together, so it's going to count if it's in either or both of the sets. So what's that going to give us? Well, we're going to add the 60, the 47, and the 38 because they're all part of the B prime, and the 41 and the 93 and the 87. And then the 59. We have to add all those together. And then we have the M union B prime, the number in M union B prime, or the cardinality of the set M union B prime.